Hello, welcome to my video. My name is Didem Topuz and I'm an architecture student at Okan University in Istanbul. I am currently working on my master's degree, and for this course, for this project, we will talk about ecologic high-rise buildings. This course was coordinated by Dr. Semih Eryıldız. In introduction part, we will basically talk about the historical part of the high-rise buildings, technological developments that led to the high-rise buildings that were constructed today. We will look a little bit about the sustainable insights of the buildings, what sustainability is and its relation to high-rise buildings. And at the end of all of this research, we will make another project proposal with the collected data. So when we look at the history of high-rise buildings, we see that in early historical development, in human development, we also built some high-rise buildings, or monuments would be a better term for explaining it, because there were not people living in it, but it was just like a military or religious symbol back in the time. Let's get to the question of what is high-rise building? What do we consider a high-rise building? For the tall buildings and urban life council, there are three main categories. One of them is height relative to context. That means we have a building in our hands with 14 stories. It is considered a high-rise building in a suburban area, but it's not really considered high-rise buildings in or metropolitan cities where we already have a lot of high-rise buildings. The second headline would be proportion. Depending on the proportion, it may appear high because it's very slender, but it could seem not so high or a little bit shorter because of the wide footprint and wide size areas. The third one is embracing technologies relevant to tall buildings. If a building has specific traits such as vertical transport technology, structural wind bracing as a product or height, it can also be considered as a tall building. So, of course, when we look at this, we can understand why we couldn't make high-rise buildings in the past, because we didn't have those technologies to hand. We come to the part of philosophy of the Erise buildings. What even is sustainability? We have in the 21st century a serious problem with growth of population. Economic power is rising. Governments that have enough money started to constantly planning new buildings with unique designs. When we are talking about sustainability, we have to be aware of the sources of the world we live in. We have to use inexhaustible supplies. We have to reduce the carbon footprint that we have. We have to work with materials that we can reuse or recycle. We can basically analyze this sustainable architecture with three main headings: environmental reasons, social reasons, and economic reasons. Can skyscrapers be sustainable? This is another question. The positive thing that can a skyscraper give us is less land use, since land is getting more expensive each day. We can fit a lot of more people inside of a high-rise building than we can do in another regular building, and it's let's say a habitat that works in its own itself anyways, so we can just integrate the sustainable materials or sustainable systems inside of the building, which brings us to sustainable skyscrapers. Here you can see again a small diagram, a small table of bioclimatic design approaches in traditional longhouses, such as structural design, where ventilation openings, materials, daylight. We have a lot of opportunities to do that. And this, of course, we have the two most important and inexhaustible sources. That would be the sun and the wind. According to that, we can also shape our buildings. Let's look a little bit about the examples of how to make a skyscraper more sustainable. One of the most important ones is locally sourced construction materials. Here we have an example of a building who was built that way, the Bank of America building. They used locally sourced materials, 40%, and for that they also had less energy of getting materials from another country. The second thing would be wind-resistant design. The Shanghai Tower is a good example for that, with its curved spine. who was ingeniously incorporated in order to redirect wind force, allowing for a less resource-intensive construction. Another example is the green buildings, with the example of the Oasia Hotel downtown in Singapore. It has a vertical vegetation on the whole building. The aim was to reduce the building's carbon footprint and creating a beautiful, relaxing, and natural environment for the residents. Wind turbines are also another way to make a building more sustainable, with the example of the Bahrain World Trade Center. They have the wind turbines directly integrated into the building itself and have saved energy efficiently. And the last example would be temperature regulating facades, like we see in the example of the Ping An International Finance Center in Guangdong. Let's look a little bit at the historical development of the tall buildings. As I said before, in the earlier times, there were also high monuments built. There wasn't really active people living in there, but they were like symbolically for the people living in there. A good example of that is the Tower of Babel. It was located in the country of Shinar in Babylonia. It is not existing today. We have just the ruins. The second example would be, of course, the Egyptian pyramids with the Great Pyramid of Giza. It has a height of 146.5 meters, and it was the world's highest structure in the world for 3,800 years. And then the construction of Lincoln Cathedral in 1311 began. Let's look at the development history of high-rise buildings. Where did they start and why did they start? In 1880s, there was a big fire in Chicago and New York. This big fire destroyed almost all of the city itself. So these people had to rebuild the whole city from scratch. So they had to build higher than to increase the base because of high cost of land. And the construction of the high-rise structures was based on that original concept. One of the earlier examples of that would be the Chicago Home Insurance Building, was built after the Great Fire by William Lloyd Baron Jenney. It's 12 floors high, and the phrase tall office building was firstly used and made known to the public back then with this building. Here you can see some plan examples of the building, some details about it. You can also read some details about the building here. It includes inner skeleton of steel, vertical columns, and horizontal beams. It's contrasted sharply with older constructions. Rather than wood, new structures in Chicago are mostly composed of stone, iron, and steel. This is all new material introduced to architecture. This brings us to the review of before 20th century architecture. As you can see, we have looked at a few examples in the past. And after the building that we have seen before, we come to the second building, the Monadnock building. It's representing a traditional period in architectural history. There is a transition inside of the building. It goes from load bearing to skeleton frame construction. Both of them are working equally in two halves. Let's look at the details further in the plans. Like you can see here on the north side, it's different, and on the south side you can see brick and terracotta exterior. On the north side you see load-bearing walls. The differences you can see also in the sections. So let's look at the technological developments in high-rise buildings, because this is going to affect our view to the high-rise building construction a lot, since this was a big handicap for us in building high-rises. The first and one important thing would be the elevators. The elevators were also were already existing back in the time, but they were using to carry goods, not people. However, in the late 1815s, the change from transporting products to carrying people occurred. So they started in 1857 in New York's Hogwood department store to carry people, but the people were, of course, at the beginning hesitant and were really scared of it. They didn't want to use it. And at the beginning, it was really unsafe. But at the end, they developed it and got the first patent for vertical railway by Elisha Otis. And then it started to be getting involved in the high-rise buildings that we see today. This was a big improvement and a big development for high-rise buildings. You can see and read along the details here if you want to. Another important thing is plumbing. Plumbing has solved a lot of problems that we see in high-rise buildings. One solution would be raised storage tanks at the top of the structure with fill pumps at the bottom. Gravity downfeed configuration this would be. This technology evolved into direct pumping systems that employed numerous pump packages with constant speed and constant pressure controls. This brings us to our examples of ecologic high-rise buildings. This one is called the Swiss Straw building, also known as the Gherkin. It's located in London, made by Norman Foster. It's one of the first skyscrapers in London with environmental. The shape is important when you look at it, and there are lighter colored windows and darker colored windows. The darker colored windows you can actually open to get wind flow inside of the building, and the lighter colored windows, they are permanently closed. It's an aerodynamic design to enable wind to flow around the building's facade rather of being deflected downwards at the ground level. It also proposes a link between nature and the workplace. The diagonally braced structure provides column-free space and totally glass front, which opens the building to light and vistas. There are a lot of important details to this building. You can read through. We have some examples from a few close-ups. Like I said, the darker colored windows are opening, and then you get a nice and good ventilation inside of the building, the airflow. Here we can look a little bit about to the sketches that were made by Norman Foster itself, design ideas, some plans and sections, and the site plan. The second example is located in Canada, in Calgary. It's called The Bow. It's also made by Norman Foster and Eberhard Zeidler. It's the first phase of mixed-use project for 2 complete city blocks of the east side of Center Street. The important thing is the tower faces south, bending towards the sun to maximize lighting and heat, while the resulting bow-shaped layout, which gives the tower its name, maximizes the perimeter for cellular workplaces with views of the Rocky. The glass facade is dragged forward to form a sequence of atria that span the whole weight of the tower when the structure turns inwards. These areas serve as climatic buffer zones, insulating the structure and reducing energy use by roughly 30%. Here we have also some sections and plans, pictures, images from the inside and outside of the building. The next example that I will show is the Hearst Tower, one of the most important buildings, also made by Norman Foster. It's located in New York, and it's New York's first green high-rise building. It has been made with a diagram facade. This brought us to 21% less steel than normal buildings have to use. It's also 85% recycled steel, and its heat and air conditioning system uses outdoor air, front cooling, and ventilation for 9 months of the year, which brings us to 25% less energy than normal office buildings. The building has also high performance, low emission glass with inbuilt roller blinds that may be developed to decrease glare and reduce solar gain. Here we have some examples of the section and the site plan. Here you can see some more examples of the sketches that he made. The next example brings us to Germany, to Frankfurt. Also, this is the Commerzbank headquarters, also made by Norman Foster. The building's layout is triangular with 3 petals, the office levels and the stem created by a full-height central atrium. The building's carrying system is located at the triangle's edges, at the corners. Let's look a little bit at the details. Response to prevailing winds and solar orientation is naturally ventilated for 60% of the year with the sky gardens. Office areas are naturally ventilated and flooded by daylight. The tower consumes 20% less energy than predicted and gray water circulation. Here you can see some sketches, some sectioning of the building, some plan details. As we can see, the carrying system is always on the corners, and in the middle we have the atrium. And here you have a good example of how the ventilation actually works inside of the building, the natural ventilation and the gardens and the atrium. The next example is Pearl River Tower. It's located in Guangzhou, China. It's a 71-story building. It's designed to minimize environmental impact by extracting energy from natural and passive forces surrounding the structure. The technical integration of form and function in a holistic approach to engineering and architectural design is a major accomplishment. The 4 steps that were taken by approaching the design. 1, reduction. This includes using low discharge ventilation, daylight responsive controls, radiant cooling, demand-based ventilation, and high-performance glazing. 2nd would be absorption. This includes using wind turbines, daylight responsive controls, and integrated photovoltaics. 3 is reclamation. This stage includes using exhaust air, heat recovery, and chillers. For generation, this final stage works to achieve the objective of being a zero energy building by creating sufficient energy on site using microturbines. The structure confronts the prevailing winds, which it employs to alleviate the structural constraints caused by strong wind pressures. Here you can see a plan and the site plan of the building, some sectioning and a sketch who explains you how the building is working together with wind. And here we also have, again, the shape and the wind relation, which you can see better than the sections. Okay, this would be it for this presentation. Now we're going to look at our own design according to the researches that we have made, how we can use it in our own designs and how we can propose a good example like those. Now we have here the design proposal for our own high-rise building. We have a complex program. The main idea is to make an adaptable design with a use-neutral complex plan. Since we are going to build a skyscraper, our primary goal is to solve the building's core, which is the building's center. We have a proposed space program, what must be inside of the building and what we can integrate inside of the building. This is, of course, not the final space program, it's just a proposal. Our location, proposed location for construction is in Doha, in Qatar, because it's a capital center of Qatar and the key financial center, and it's rising right now. Also in the world, it's a growing metropolis, and it also gained some popularity with the World Cup in 2022. We have made some analysis about the climate. Of course, we can see that Doha is a deserted climate. There is hardly rain throughout the year. Some analysis on cloudy, sunny, and rainy days. We can surely say that in Doha there is almost no rainfall during the year. The weather is mostly sunny all the time, hot, and of course humid. This will affect our design in high-rise building, but sun shading or glazing designs. We have some wind analysis. This will help us further in the design of the outer core, outer design of the outer shell of the building. We have a strong wind coming from the northwest side, so we will use that for our building design. We have some sun diagrams showing where the sun is going down and coming up. Some public transportation analysis. All of the lines that we can see here are finished and finalized. There will be added some more in 2025. Flora and fauna is actually pretty rich in Qatar. You can see 300 different varieties of wild plants. Also 21 different types of mammals. There is a big list where you can read through when you want to find out about Qatar's fauna. There are 215 common birds, 21 different species of lizards, and 165 different fish species. For the first approach, the possible construction areas that we have thought of were these ones. This one's, and because this is the West Bay, aside from the city's existing high structures, several super tall skyscrapers are on hold. So this gives us the perfect opportunity to buy our own high-rise building at this location. And this is also the commercial and economic center of the city. Here you can see it again from afar, how it looks like. Our building will also be a part of all of this crowd. And as you can see here, it's located in the commercial office area and showrooms. About the sustainable proposals on our high-rise building, we will, of course, even if it's less than other countries, we will be collecting rainwater. We will also use gray water in our building. Wind is going to be an important part in our designing process since we have a strong wind coming. This is our proposed space program. We have get together all of the things that we wanted in our building, and coming together, we have a total approximately working space of 18,000 square meters with 45 floors above ground and 3 below ground for parking. This is a site plan from the general area. This was the proposed area before, but we have changed that. And in a bit, I will show you the final results of our all analysis and our final product. So now you can have a final look at our gathered information about the gathered analysis, what we have here. The final construction area will be on this position. It's still in the West Bay, as we said. We have brought together all of the analyses that we have made. And from the final area that we are going to use, and here you can see our building, it's black. We have also made, again, some analysis about the site. We can see it's mostly flat, so this gives us a big opportunity to buy on it, build on it. And here on the next part, we see from our building, of course, we will show you a finished version of the product as well of the building. This is just a section plan on how the building works. The designing process, considering climatic features, how we came up with the idea that this is a traveling shape. It's because of the wind that we can use the wind. We have some glazing and ventilation detailing, double glazed windows, reduce for heat gain, controlling inner surface temperature, and of course, the airflow. As said before, the area is a pretty humid area, so we're going to use moisture harvesters so that we can use it as water again inside of our building. And this would be the final product. You can see a proposed site plan of our building, some details, how we want it to work. And as a result, as the final results, we can show you some of the render pictures that we have made. This is how it looks like when it's finally developed and inside of the city located. We have a picture from inside of the building, from the office buildings, how it looks from the inside. And some other pictures and renders. And here At the very end, just a short video so that you can see where our building is located again. We can look at it from the top, from the far away, how it integrates with the other buildings in our city. If you have made it this far, thank you for your patience. Thank you for your interest. I hope it gave you a little bit more insight on high-rise buildings, high-rise ecologic high-rise structures, of course. And thank you for listening. Enjoy the rest of the video.